This is the lock nest, and the lock I have for you today is the Fichet M3B. This lock is manufactured by the company Fichet, which is specialized in vault and safe manufacturing. The other Fichet company you may know is Fichet, which is the company which is specialized in door locks. So this lock is a lock you will find in safes manufactured by Fichet, and it's a lever lock. This is a lock which is composed of 8 levers, and the key is typical to this series of lock. There is the Fichet M2I, M2B, and MXB. This one is the M3B. The main difference with M2I and M2B is that this one has 8 levers instead of 7, and the 8th lever is the one which will interact with this interactive element, which is a ball, and we'll talk about it a little bit more later. So how this lock works, it's very simple. You put the key, you push. As soon as the key is in the lock, all the levers are set to the correct position, and the lock can turn very easily. So you may note here that this is a very short key, but depending on the type of safe you have, you may have very longer key. Sometimes the key may be more than 6 inches in length, because since this is a safe key, depending on the type of safe you have some fire safe which doesn't require high security. So the doors are small and the lock is much more embedded in the door. But for high security safe, then you will have the lock which will be far away behind the face of the door. So you will need a longer key to be able to reach the lock. So to better understand how these locks work, I will disassemble it. So here we have the complete lock. So it's composed to the outer barrel, which is the barrel which will block the levers if they are not in the good position. And you have the inner barrel with all the levers. So how it works here, I can show you. So here you can see that at rest you have part of the lever here, which is in this groove here, and this lever which is at a certain height, and you see it's different for all the levers. And when I put the key in the system, you see that there is no more levers within this groove, and all the levers here are aligned correctly. So why? It's because here you will see that at rest the levers will be blocked by this part here or here, and here too, because this thing goes directly in the groove here. And as soon as everything is aligned, then the levers will be here and we'll be able to rotate. So here, which is aligned with this part here. And for the other side, it will be in this groove and we'll be able to rotate safely. So to have a better view of that, here is a picture. So first, I will start with the picture of the key. You can see this is a 3D view from a patent of the key. You can see the key in blue and the ball in red. So for other drawing I will show you during this presentation, we will keep the same color code. So this means that the ball bearing, all the ball bearing will be in red, and the key will be in blue every time. So now we can take a look at the lock itself. So here in this picture, you can see on the left This is the lock, which is in the, I may say, the rest position. So as I explained you have the two parts of the levers which block the external barrel. So the external barrel is in yellow here, and the internal barrel is in gray, like in reality in the lock we have. So you can see at rest on left, the lock is blocked, can't rotate because of the lever here, which block the rotation, and the lever at this position too. As soon as we enter the key, you can see on the right, for example, then the lever will align with the free space, the grooves in the external barrel, and then this is why the system will be able to rotate. So if we come back here, so you can see clearly the space we talk about for the groove and the levers. So now what's interesting is to see how the levers are assembled and how it works. So I will disassemble the inner barrel. This is disassembled. I will remove the back plate. So here it is. You can see all the place where the spring goes. And here is our lock. So you can see the springs. You can see the levers inside. And something which may seem obvious is that here you have a spring which is really not like the others. And I will talk about that later. This is for the interactive element. So something important while manufacturing and designing this kind of lock is that the system is circular. And when you have a circular system, the main issue you have is that everything which is close to the center of the lock is very close. All the parts are very close together. And this creates several issues and which need to be overcome during the design process. One of the most obvious we can see without disassembling the cylinder is the key. When we look at the key like that, it seems that, okay, it's a symmetric system and no problem with that. There is a machine which create the key, etc. But if you check that in more details, I will zoom on the key. You can see here that the groove in the key here, for example, I try to show you clearly here. Sorry. Yep. Here you see the system is not perpendicular. The cut has an angle here. And if you check the angle, it's the angle which allows to go over this thing here. So in fact, they had to make this not perpendicular like that to prevent the machining system to go and damage this part while you are cutting this one. So they put a system like that so the cutting machine can come here and cut it correctly. So this is the first things. Now there is another issue is that as you can see on the picture we saw previously, on the levers you have point of rotation, an axis of rotation, which is in red if you look correctly. And why this is in red? Because as I said previously, what is red is the ball bearing. So here, if we look at this lock, in fact, the axis of rotation of the levers is here, very close to the center. So if you try to machine something, you have very small place. And if you want, for example, to put from here an axis of rotation, like a pole, a small pole or something like that, it will be really difficult to make it fit correctly and horizontally like that during the assembly process. So what Fichet decided to do is, instead of using a pole, which is difficult to set horizontally inside a small hole like that with few space, they decided to use a ball bearing. And I will try to remove this, this lever to show you exactly how it looks inside. So here you see the lever and the ball bearing which comes with it. So here you can see, so you have your lever and the ball bearing is used to rotate. So since there is the spring here which push on the lever, this lever will stay at the bottom of the system and will not move up. So here the system can rotate, and in fact, as we talked before, the key comes here, exactly in this spot, like that, to set the lever correctly. And this is this part and this part which block the system from rotating if there is not the good position. So now there is the second interesting system is the one made for the interactive element. So in fact, this system is slightly different, and I will explain why. First, here we have a spring which is way stronger than the other ones. Why? Because in order to position the lever correctly for the interactive element, we need to apply a strong force, because the ball need to roll between the lever and the key system and go in a very specific position. Furthermore, the lever has more room for movement. So in order to be sure everything will move correctly, even if there is dust or rust or whatever system which try to prevent it to work correctly, it needs to work. So you put a lot of force on it, so the chances everything will go in a good position is higher. And because of that, they had to do something special for this one, is that they had to put a ball bearing at the just between the lever and the spring. You can see it here, in order to allow the spring to move on the lever without bending and without being damaged. Because this lever, because of the mechanical movement which will be implied by the system, they had to. I will remove the ball bearing. No, I remove the system, the lever. Yep. So here you see that for this one, when the system, the key enters in, the ball will go here. And there is some room to allow the system to move and to allow the ball to position correctly without creating any issue. So if the ball, the center of rotation here moves, the spring which push here may move too. So we have to ensure that no issue will happen because of that. I will show you how it works exactly using some drawing. So here you have 3 examples of the ball bearing in different positions. So on the left, which is the figure 1, you can see that the shape of the levers of the lever implied that the ball bearing will move up to the top. And then because of that, the lever will be at the good position. On the figure 2, then the position of the ball should be in the middle. And on the example 3, we can see that it's at the bottom. So in fact, it's the lever which will set where the ball bearing will be. So you may say it may be possible probably to create a key which will be able to work with that, but not sure it will be really easy or it will work efficiently depending on where the system expects to have the ball. Now, on a picking perspective, it's possible that this may not make a huge difference. However, since we have seen that the axis of rotation may change because of that, it's possible that just pushing up and down may not allow to position the lever perfectly, and that it may be required to position it vertically and horizontally a little bit to ensure that everything is set correctly. So here it is for this lock. If you are interested in this kind of lock, you can take a look at my eBay store. There are some available from time to time. If you want to see more video like that, you can subscribe to my YouTube channel or follow me on Facebook, and you can see pictures of cool locks on my Instagram page too. So thank you very much and have a nice day.